This is a question from absolutely no one, and that makes it even more important to answer. If you're like most people, you've probably never looked at a fast-moving train and thought, you know what could stop this? Italian cuisine. But science isn't always about what's practical. Sometimes it's about what's possible. So today, we're going to find out, how many lasagnas would it take to stop a train? Let's start with the train. We'll assume it's a fairly standard passenger train, something like an Amtrak or European high-speed line. Let's say it's moving at 200 kilometers per hour, or about 124 miles per hour. That's pretty fast. Fast enough that if it hit a cow, the cow wouldn't win. Not even close. Now we need to know how much this train weighs. A typical high-speed train might weigh around 400 metric tons. That's 400,000 kilograms. And since we're dealing with kinetic energy, that lovely I'm going to crash into something energy, we need to use the formula E equals 1/2 mv squared, where m is the mass and v is the velocity. So half times 400,000 kilograms times the square of 55.6 meters per second is approximately 617 million joules. That's a lot of energy. It's roughly equivalent to 150 kilograms of TNT, or about half the explosive power of a small Hellfire missile. Our lasagnas are going to have their work cut out for them. But wait, before we start flinging pasta at a train, we need to understand something. How stoppable is a lasagna? Let's define our lasagna. We'll say it's homemade, not frozen, because frozen lasagna is a cheat code, and we're here for science. One lasagna is about 40 centimeters by 25 centimeters and around 7 centimeters thick. That's roughly the size of a big family casserole dish. Let's say it weighs about 4 kilograms. But more importantly, how does a lasagna behave when struck by a train? Lasagna is squishy. It's layered. It has structural integrity for like half a second, and then it collapses into a steaming pile of noodle soup. So realistically, a single lasagna would absorb not much. The train would vaporize it instantly. The lasagna's only hope is accumulation. If you stack enough lasagnas in the path of the train, eventually they'll provide enough resistance to slow it down. Kind of like a giant, delicious brake pad. So now, the real question is, how many lasagnas do you need to stop 617 million joules of energy? Let's try to calculate how much energy a lasagna can absorb before being flattened into irrelevance. We'll make a bold but semi-reasonable assumption. A lasagna can absorb the same amount of energy as a soft, moist stack of paper, about 10,000 joules per cubic meter before total squishification. A single lasagna has a volume of about 0.07 cubic meters. Multiply that by 10,000 joules, and each lasagna can absorb around 700 joules of energy. That means we'd need 617 million divided by 700 equals approximately 881,000 lasagnas. Almost 1 million lasagnas. That's enough to feed Italy for a week, or Garfield for 3 days. But wait, that's assuming the lasagnas absorb energy perfectly, like little pasta-shaped airbags. Reality is a bit crueler. When a train hits a lasagna, most of the lasagna gets splattered to the sides, not pushed. It doesn't actually resist the train very much. We have to take into account a concept called momentum transfer, and sadly, lasagna has the same stopping power as a very determined pudding. So let's do this differently. Let's think in terms of force over distance. We need the lasagna stack to apply enough force over enough distance to stop the train. That's the impulse momentum theorem. F times t equals delta, more or F times DO equals mv squared over 2. We can rearrange this and ask, if the lasagna stack is, say, 1 kilometer long, how much force would it have to apply to stop the train over that distance? Using the train's mass and speed, 400,000 kilograms times 55.6 meters per second, squared divided by 2 times 1,000 meters, is approximately 6,170 newtons of average resistive force over 1 kilometer. That's doable for, say, a concrete wall, but not for lasagna. To apply that kind of resistance using only soft, gooey layers of pasta and cheese, we'd need so much lasagna that the train physically couldn't get through it. The wheels would start to spin, the motors would overheat, and the train would just slowly grind to a halt, partially from resistance, partially from embarrassment. At this point, the lasagna is less a food and more a terrain. You've turned the track into a carbohydrate swamp, but we can go further. Let's figure out how much space this takes. Each lasagna is 0.07 cubic meters. Multiply by our earlier estimate. 881,000 lasagnas, and you get a volume of about 61,670 cubic meters. That's about 25 Olympic swimming pools full of lasagna. Now imagine that spread out over a train track. It would be about a kilometer long, half a meter deep, and completely impassable. You wouldn't just stop the train, you'd bury it. And then there's the thermal problem. A train going at full speed hitting that much mass would generate a massive amount of heat. The lasagna would cook itself. Literally, the first few 100,000 lasagnas would vaporize on impact. Cheese shrapnel would fly in all directions. It would smell amazing for a second, and then be horrific. Also, the track would be gone. Not just covered, gone. Steel rails are not designed to handle marinara overload at supersonic force. At this point, we may have stopped the train Manaido, but we've also invented the most inefficient, delicious disaster in transportation history. But wait, what if we cheated? What if instead of soft, floppy lasagna, we froze it? Say to minus 40 degrees Celsius. Now it's hard as rock. Suddenly, we're dealing with something closer to, well, lasagna bricks. Frozen lasagna could absorb more force before deformation, maybe 10 times more. So now you only need 88,000 lasagnas. Still a lot, but much more reasonable. That's only 2.5 Olympic pools, or one very well-prepared Italian restaurant. Still, the train would not enjoy hitting them. Even if you space them out, like lasagna, speed bumps, the cumulative force would eventually bring the train to a shuddering halt, or derail it completely, which is kind of a win. In the end, could lasagna stop a train? Yes, eventually. If you had close to 1 million lasagnas, frozen or not, and you laid them out correctly and the train didn't cheat by braking, then yes, the lasagna would win, at a terrible cost. But the real question is not could we do this? It's why would you? Unless you're trying to stop a train with leftovers after a family reunion gone horribly wrong, this is probably not your best option. But still, if anyone ever tells you food can't solve big problems, just remember, with enough lasagna, you can stop a 400-ton train. And honestly, that's beautiful.